Have you ever wondered how cement, the backbone of modern infrastructure, is made? Do you know what constitutes cement and its components? Or do you know the origin of cement? Indeed, these are questions that may not cross our minds too often because they are taken for granted. Yet, cement is an integral part of our built environment, quietly holding up the structures we live, work, and play in. From towering skyscrapers to the humble sidewalk, cement is everywhere, and that is the truth. Even when you want to underplay its importance, cement cannot be ignored. It provides the bedrock, the foundation which stabilizes our structural building environment. So the question is, how does this all-important material come into being? My dear friends, the process of cement production is a fascinating journey, involving a blend of science, engineering, and art. Today, I implore you to sit back and listen attentively till the end of this video as we unravel the mystery of cement. It starts with the extraction of raw materials from the earth, leading to a series of rigorous processing stages. Each step is meticulously designed to transform the raw elements into the fine grey powder we recognize as cement. So, how does this seemingly mundane substance come to life? Let's dive into the fascinating world of cement production. After all, there's more to cement than meets the eye, and there's a whole lot of science behind every single building block. First things first, everything starts with the right ingredients. In the case of cement, our main ingredients are limestone and clay. Now, you may be wondering why these two? Well, limestone is a sedimentary rock, abundant and easily accessible. It provides the calcium needed in the creation of cement. Clay, on the other hand, is our source of silica, alumina, and iron, all essential elements in the cement mix. These raw materials are usually sourced from quarries, often located near the cement plants to minimize transportation costs. Once they are extracted, the limestone and clay undergo a series of processes, including crushing and mixing, to create a perfect blend. This blend is then ready for the next stage in the cement production process. It's quite fascinating to think that these simple natural materials, found beneath our feet, form the backbone of our concrete jungles. Now that we have gathered our raw materials, it's time to start the transformation process. The magic begins when these raw materials are subjected to intense heat. Yes! Intense heat! Take note, when we say intense, we're not talking about a sunny day at the beach. We mean a blistering, searing, furnace-like heat that rivals the surface of the sun. The raw materials we discussed earlier are loaded into a massive cylindrical kiln. Take note, this is no ordinary oven, but a feat of engineering that can reach temperatures of around 1400 degrees Celsius. That's much hotter than molten lava. Oh yes, definitely hotter than molten lava. In this sweltering environment, the raw materials undergo a series of complex chemical reactions. The limestone starts breaking down, releasing carbon dioxide into the kiln's fiery atmosphere. This forms calcium oxide, which then reacts with the other elements present, such as silica, alumina, and iron oxide. As these elements dance in the heat, they begin to form new compounds. These compounds, known as elite, belite, aluminiferrite, and silite, might not sound familiar, but they are the unsung heroes of our story. Each of these compounds contributes unique qualities to the final product, from strength and durability to setting speed. As the temperature continues to climb, the materials start to coalesce, forming small, hard grey nodules. These nodules are hotter than any desert sand and harder than the toughest granite. They tumble around in the heat, growing and solidifying until they resemble small, rough pebbles. This is the birth of a substance we call clinker. Strange, isn't it? Clinker is the raw, unrefined heart of cement. It's a testament to the transformative power of heat and the complex chemical ballet that takes place in the heart of the kiln. It's the result of intense heat, immense pressure, and a series of chemical reactions as complex as any you'd find in a high-tech lab. The result of this fiery process and this resultant new substance, aptly named clinker, is the precursor to our final product. This clinker, once cooled, will be ground into a fine powder, setting the stage for the next chapter in our journey through the magic of cement. Next, we grind this clinker into a fine powder. This is a momentous step in our journey of cement creation. It is noteworthy that the grinding process plays a crucial role in defining the final product's texture and performance. So how do we achieve this? It's quite fascinating, actually. We use large rotating drums filled with steel balls. As the drums spin, the clinker is pulverized into an ultra-fine powder, a texture akin to that of talcum powder. The power of friction and impact between steel balls and clinker fragments transforms our hard, pebble-like clinker into a fine, silky powder. But we're not quite finished yet. There's a special ingredient that we need to add: gypsum. Gypsum is a soft white mineral, and it's the secret behind controlling the setting time of cement. Without it, cement would harden too quickly, making it difficult to work with. So we sprinkle in a dash of gypsum during the final grinding process. This seemingly small step has a big impact. It gives the cement enough time to be molded into any shape before it sets and hardens. Through this remarkable process of grinding and the addition of gypsum, we have taken a step closer to the final product. And just like that, we have transformed our clinker into cement powder. It's a testament to the magic of science and technology, isn't it? Indeed, the journey of cement is a tale of transformation. Finally, our cement is ready for the world. But before it can become the backbone of our modern infrastructure, it has to reach its destination. And that's where packaging and distribution come in. Once the cement has been ground into the fine powder we're all familiar with, it's conveyed into a packing machine. This is where the cement is divided and sealed into standard-sized bags, usually made of paper or polypropylene. These bags, which typically weigh around 50 kilograms, are then stacked and prepared for transportation. Distribution is a crucial stage in the journey of cement. It's transported by various means: trucks, trains, even ships, to reach construction sites and stores worldwide. The distribution process is carefully managed to ensure that the cement arrives in perfect condition, ready to be used by builders and DIY enthusiasts alike. But it's not just about getting the cement from A to B. Proper storage is vital to prevent the cement from reacting with moisture. If cement comes into contact with water, it starts to harden and become unusable. That's why you'll often see cement stored under cover, away from the elements, whether it's in a builder's merchant yard or your own garden shed. So, from the packaging line to the construction site, every step is meticulously planned and executed. And that, my friends, is how cement, the backbone of our modern infrastructure, comes to life. Cement might seem like an ordinary substance, but its production is nothing short of magical. The transformation from raw materials to a powdery blend, the intense heating process, the meticulous grinding, and the final addition of gypsum to give it that perfect set. And voila, we have the backbone of our cities, our bridges, our homes, all thanks to this remarkable process. So the next time you see a building, a bridge, or a road, remember the fascinating journey of cement from raw materials to the sturdy structure you see before you. Before we wrap up, we have a small request. If you enjoyed this video and learned something, don't forget to hit the like button and share it with your friends and family. Also, let them subscribe to our channel and make it a habit to join us regularly.